Welcome back. Today we will see about the Bayes classification. So Bayes algorithm is a supervised learning algorithm which is based on Bayes theorem, and it is mainly used for solving the classification problems. And it is mainly used in text classification that include high dimensional training data set. And it is a probabilistic classifier, and which means it predict on the basis of the probability of an object. It's mainly comprises of two words, naive and bias. So naive means the occurrence of a certain feature. It is independent of the occurrence of other features. So for example, if the fruit is identified on the base of a color, shape and taste, then there will be another fruit will be coming with a red, spherical and sweet fruit, can be an apple or can be an orange, like that we are predicting. That is name. So the occurrence of the feature. Bayes means it will be depending on the principles of Bayes theorem. So combining with these two terms, it came naive Bayes algorithm. The naive Bayes rule is the probability of hypothesis with prior knowledge, and it will be depending on the conditional probability also. The formula of the Bayes theorem is probability of A by B equal to probability of B by A into probability of A divided by probability of B. Here, probability of A is called posterior probability, and probability of B by A is called likelihood probability, and probability of A is called the prior probability, and probability of B is called marginal probability. So probability of A by B equal to probability of B by A into probability of A divided by probability of B. So the working of the Bayes algorithm can be understood with the help of the following example. So now we are giving a data set of weather condition. So it can be so many like windy, sunny, like that conditions will be there, and there will be a corresponding target. The target variable will be play. So we can decide in this particular weather condition, the player will or like a student will play or not. So like this, like probability calculating and we are predicting. For that, we are using this Bayes classifier algorithm. We have actually minimum four, will be there 4 steps for finding the Bayes classifier. Sorry, 3 steps. Convert the given data set into frequency table. Generate the likelihood table by finding the probability. And third one, applying the Bayes theorem. Okay. Finding that first we are finding the frequency. Second, we are finding the likelihood table. Third, we are just applying the Bayes theorem. So now we'll see a problem. So here the question is if the weather is sunny, the player will play or not. So they are given 14 data sets. Okay. And this is the outlook and display. So this test case 1, that means like here it is mentioned 0 to 13. So 0th case, in a rainy day, first person, I am taking the sample of 14%. The first person in a rainy day, he will be play. Okay. Maybe there will be another person, see the case number 8. It is a rainy day, but that person number 8 is not playing. So like that, by that we are written the test cases. Okay. So from here, first we will write the frequency table for the weather condition. So how many weather we have actually from here? We have rainy, sunny, overcast. Okay, rainy, sunny, overcast. We have three weather is there. So we will write the heading weather and the conditions are yes or no. So in the overcast, how many yes? In the overcast weather, how many people will play? Yes. So here overcast yes, here one more yes, here yes, and one more yes here, and last one. So in overcast yes is how many? 5. In the same overcast, how many players are won't play? There is no. Okay. So here it is no. 0. In a rainy day, there will be 2 persons are playing, right? Here yes, one more rainy yes. There are another 2 persons not playing in rainy day. So here rainy will be no. And the sunny day, same thing. 3 people will play yes and 2 people will play no. This is called the frequency table. From the frequency table, we are writing the likelihood table. So likelihood table means the same values we are written here. Overcast 0 and 5, 2, 2, 2, 3. And total overcast will be 5. And then the probability of overcast, that is 5 divided by total cases how many? 14, 0.35. Next, total rainy is how many? 4. In 4, probability of a rainy is 4 divided by 14, 0.29. Sunny, 2 plus 3, 5. 5 divided by 14, 0.35. And now this side what we return, whatever condition there is the chances of the no is 4 divided by probability of no in whatever condition no is 4 divided by 14. And the probability of yes is 10 divided by 40. Total we are taking and 40. Okay, so now we got likelihood table. Now, what is our next? The third step is we are applying the Bayes theorem. So, what is the Bayes theorem? The Bayes theorem is probability of A by B, probability of A by B equal to probability of B by A into probability of A divided by probability of B. Okay. Now we will find out what is A and what is B. So always the things like in this question they ask like in a sunny day player will play yes or no. Okay. So that particular situation that we have take it as A, and in a sunny day like the condition will take it as B. Okay. So we have to find out in a sunny day player will play yes or no. So the condition is probability of yes in sunny and no in sunny. So A and B while taking the condition he has to take is A, and in the particular situation will take it as B. So probability of this is A and this is B. According to our Bayes formula, probability of A by B equal to probability of B by A. That means probability of sunny by A into probability of A, yes, divided by probability of sunny. Okay, so probability of sunny by S. What is probability of sunny by S? What will you do? We have to go here. Here, okay, this table I kept here. So, sorry. Yeah. Okay. In this table, we'll come to know probability of sunny by S. What is that sunny by S? Total probability of sunny. It is 3, right? So, 3 divided by 3. Yes. So, probability of this 3. 3 divided by 10 equal to 0.3. Then, probability of sunny. Probability of sunny here I told you 5 divided by 14, 0.35. Then probability of yes, where we'll see here 0.71. So 0.3 into 0.71 divided by 0.35, it is 0.60. Now next is the person will know in a sunny day. This is A and this is B. Okay, so A by B equal to probability of B by A, sunny by no into probability of no divided by probability of sunny. So first, probability of sunny by no. So here in the table you see probability of in a sunny day. In a sunny day, what is the probability of no? 2, right? So 2 divided by 4. What is 4? Total number of 4. Total number of no is 4. So 2 by 4. Okay, here also see 3. Here sunny yes means total number of sunny day yes is 3 and total it is 5 plus 2 plus 3, 10. That is here 3 by 10. Same thing here. Probability of a sunny day is 2 and total no is 4. That is 2 by 4, 0.5. And probability of no is 0.29. Then probability of sunny where we'll see here. Probability of sunny is 0.35. So 0.35. 0.5 into 0.29 divided by 0.35, it is 0.41. So now we have to see this probability of yes in sunny is 0.60 and probability of no in sunny is 0.41. So we'll compare now. Which is greater? this is greater, right? So we have to write the probability of yes in sunny is greater than probability of no in sunny. So what is your assumption is in a sunny day, player will play the game. Okay. So this is like this, we have to solve the problem. So the first step is, okay, we'll go through once more. First step is we are finding the frequency table by seeing from the table how many rainy, how many sunny, all this, and then yes or no we are filling, and from that we are finding the probability. And here also we are finding the probability of no, probability of yes, probability of overcast, probability of rainy, and probability of sunny. This is called likelihood table. After likelihood table we are getting, then we are applying the Bayes theorem. Okay, and from the Bayes theorem, we have two conditions, and which is greater, accordingly, our prediction will go. Okay, like this, we will solve the neighbors problem. And the advantage of neighbors problem is it is one of the fast and easy machine learning algorithm to predict the data set, and it will be like multi-class prediction is possible than any other algorithms, and most popularly we are using for text classification. And the disadvantage, if you want to tell, means we can tell it is actually all the features are independent or unrelated, so it cannot be learned the relationship between the features, that we can tell as a disadvantage. So where and all we are using this base means it is mainly used for credit scoring and medical data classification or real-time predictions of the equal learners, and spam filtering and sentimental analysis we are using for this neighbors classification. Okay, so I think hope everybody understood this neighbors algorithm. Thank you.